Hello, good morning, everyone. Once again, I'm Teacher Renzo, and I will teach you all the matters here in science. Okay, but before we proceed that, I want to welcome you in our asynchronous day. So it's time for our asynchronous day. Okay, wala nang paligoy-ligoy pa. Gusto ko nang mag-aral tayo at matuto tayo sa panibagong topic natin. Okay? Ito ay konting review na lang sa inyo kasi ito ay napag-aralan nyo na before sa inyong grade level, no? Nasa past grade level ninyo. So ito na lang is dagdag kaalaman at ito ay isang pagre-refresh na lang, no? Para makatulong sa inyo upang madali nyong masagutan ang inyong mga activities. Okay, diretso na tayo. So, ang pag-uusapan natin ngayon ay tungkol sa Thiele's equation and Snell's law. Okay? Ano bang meron dito? So, atin munang alamin ano ba ang lens. Okay? A lens is an optical device like a mirror. The only difference is it allow light pass through. Unlike mirror, hindi siya dumadiretso kasi meron siyang cover sa likod na siya ang naghaharang para ang light ay mag-pass through doon. Okay? You will be able to discover how light bends as it passes from one medium to another medium. You have observed that the bending of light is different from medium, every medium, because of its refractive index. Now let's talk about the refractive index. But before we proceed here, in discussing here in this situation or formula, let us watch this short video to explain on you what is Snell's law and how get that formula and how to formula to formulate the formula that you can use in getting the refraction of index.
In this video, we're going to learn about Snell's law. Snell's law is a mathematical relationship developed by the scientist named Wilbur Snell, and the relationship relates the angle of incidence to the angle of refraction. A ray of light will bend when it travels from one transparent medium into another transparent medium. Light travels fastest in a vacuum because nothing's in its way, and so it travels at 3 times 10 to the 8 meters per second. This is the fastest speed that light can travel. If light is traveling in air, it's going to be a little bit slower. In water, a little bit slower than that. So just to look at an example of this, if light travels from air into water, it's going to bend slightly because it's going to go from a place where it's moving fairly fast in air and it's going to go into somewhere where it's going to move a bit slower. And so we'll end up with something like this where the light's traveling at some angle and then bends in because it slows down a little bit. So there's a couple things we can measure. First of all, we need to put in a normal line. And this is a line that we just draw in that's perpendicular to the surface of the two different mediums here. And it's from this line that we're going to measure some angles. The first angle that we'll measure is the angle of incidence. And this angle right here is going to be the angle between the incident ray, that's the incoming ray, and the normal line. The second angle that we'll measure is the angle of refraction. And the angle of refraction is the angle of the refracted ray and the normal line. So if the second medium is slower than the first medium, the ray is going to bend towards the normal line, just like we see in this example. If the medium the second medium is faster than the first medium, it's going to bend away from the normal line. So we'd get something like that going on. So Snell's law is going to allow us to calculate this angle right here, the angle of refraction, when we know the angle of incidence. And so here's the different parts of Snell's law and what they mean. So first off, we have our two different angles here. This one is the angle of incidence, and this one is the angle of refraction. And then we have the index of refraction for the first medium and the index of refraction for the second medium. Now, the index of refraction is a ratio that compares the speed of light in a vacuum to the speed of light in the medium. And essentially, it's just a number that tells us how many times slower the light is going to travel in that medium compared to the speed of light in a vacuum. These indexes are standard, they're constants, and so we can look them up in a textbook or online. Let's try using Snell's law to solve a problem. So this says, find the angle of refraction for a ray of sunlight that enters water in a swimming pool from the air at an angle of 35 degrees to the normal. So here's our equation. This is Snell's law. And the information that we know is going to be the angle of incidence. That's this 35 degrees as the light is traveling into the pool from the air. That's this angle right here. And then we also know the index of refraction. There's the first medium, which is air. And here's a little table that's going to tell us these different indexes. So here's air, just slightly slower than a vacuum. And then the other index here will be water, which is 1.33. So it's a matter of rearranging this equation to solve for the angle of refraction. So first thing I can do to rearrange this is I can divide both sides by NR to move that over here. And then I want to get rid of this sign and get it over to the other side. So I can take the inverse side of both sign of both sides. And I end up with this right here. So now it's just a matter of plugging in all of my numbers and solving for the angle of refraction. So we'll plug all this into our calculator and end up with an angle of refraction that's equal to 25 degrees. And that's Snell's law.
Okay. So, balik tayo ngayon dito sa usaping ito. Okay? Doon kanina na ipaliwanag sa inyo kung paano na-formulate yung formula na yon from the refraction incident to the uh, refraction and reflection, no? Incident of refraction and another. Okay? So here, we have here the refraction is the result of change in speed of light. Tama? Okay? Ang best example niya kanina yung sa tubig, di ba? Which the light travels through the water, magkakaroon ng ibang angle, right? Light travels in different speed at the different media. You can determine the refractive index, okay, of an object which tell us the fraction of the speed of light by this formula. Okay, this N, small letter N, stands for refractive index. So, the formula is refractive index is equal to speed of light in a vacuum divided by speed of light in a specific medium. So we have here the media and the index of refraction from vacuum, air, ice, water, alcohol, quartz, acrylic, glass, sapphire, diamonds. These are the refraction index of that media. So the higher the refractive index, the, the slower the light travels in that medium. Hence, the more refractive the light will be, there are different refractive indices for various media. So, gamitin natin yung kaninang na-provide niyang formula, which is the Snell's law, no? Is the relationship between the angle of incidence of an angle of refraction of two known media. So, we use the refractive index, no, of the first medium seen to the angle of incident is equals to the refractive index of the second medium seen to the angle of refraction. Okay, we have here a sample problem. So, the sample problem tells us the ray of the light is approaching a boundary of water at an angle of 30 degrees. Determine the angle of refraction of light ray. Please note that the index of refraction of the air is 1.003 and 1.33 for water. So, let us solve that. So, this is the sample solving. Okay? or solution. Our given is the index of refraction, okay? Which is 1.003. No, take note daw, ha? That is the index of refraction of air given, okay? And the angle of incidence is 1.0 or 30 degree, okay? And the index of refraction of the second medium is 1.33, which is water, or 1.333, okay? So, anong nawawala? We find for angle of refraction. Okay? So, from this equation, from this formula, we derive another formula. For the new formula, we have a angle of refraction is equal to the sin -1 multiplied by the refraction index of the first sin to the angle of incidence over, no, refraction index of the second medium. Okay? So, rewrite lang natin yung value nito. Okay? Then, we multiply this before we divide it. Okay? Before we get the answer. So, we have 22.09. So, the image produced by the lens can be solved using the same formula for the mirror equation. Can you still remember the formula for the mirror equation? So, ito po yun. Okay? Kung natatandaan natin, where areas d sub of 0 is distance of object from the lens, d sub of I is the image distance, f is the focus, m stands for the magnification of the lens, which is equal to the ratio of the image height to the object height, or the negative of the ratio of the image distance to the object distance. So we have a problem, sample problem here. So an object of 0.5 centimeter from a lens gives an image that is located 0.1 centimeter from the lens. Identify the focal length of the lens. And this is this, you can solve for this sample problem. Try to solve that in your notebook. Okay? I-comment mo yung tamang sagot pag napanood mo to. Okay? So, what makes a diamond shine? Okay? What makes a diamond shine? A diamond is known to be the hardest metal, right? It is made up of the three-dimensional arrangement of carbon atoms linked together by strong covalent bond. A diamond shine because of three things: refraction, total internal reflection, and dispersion. When light moves through the diamond, it is scattered, creating a sparkle that diamonds are known for. So, when a diamond is hit by light, it acts like a tiny prism and angles the light around the inside of the diamond before aiming it back towards the top and through the surface. It is now easy to determine real from fake diamond. Tama? Trained professionals need to know how the diamonds are cut and polished to make sure it is real. Okay? Nakikita niyo yung tao tumitingin, face himself or herself on a mirror. Image produced by lens can be real or virtual, reduced or enlarged, upright or inverted. We see and project image differently. So the image that you project is the combination of how you see yourself and how other people see you. It is the way to see yourself same as how others see you. What do you think is the reason why others see you differently compared on how you see yourself? So that's it for our Snell's law, no? And for the reflection and reflection of light from the mirror. Okay? And refraction, kung ano man yung gagamitin mong medium. So, thank you. I hope you gain another knowledge, another idea from me. So I think so you it can help you to answer your activity easily. Thank you for watching and